Thanks for stopping by Pete's Garage. Now in this video, I'm going to show you how I made the side scoops that go on either side of the oil cooler. It's important to have side scoop on there so the air is directed towards the oil cooler and air passes through the oil cooler rather than around it. If you don't cover up that side where the oil cooler has a space, the air is going to force itself around the back and you won't be cooling your oil as effectively as you can. Now the video is not about actually fabricating these. I'm making them out of 22 gauge stainless steel. In the fabrication process, I'm not going to go through that, but what I'd like to share with you is if you're going to do something like this where you want to make a side scoop, or you're making something else and you have very thin metal like the stainless steel, and if you can't weld it or if you don't have a welder, even if you do, I'm telling you that 22 gauge stainless steel is incredibly difficult to weld. You need a very small torch, very small, it's very, very difficult. So if you are going to make something like this, what you can do, the alternative is to solder it. Now, soldering stainless steel is very difficult. Well, it's more difficult. I'm not going to say it's very difficult. It's more difficult than soldering lead. When you use, when you solder copper. When you're soldering copper, the copper is very effective at transferring heat, so it heats up quickly. You can use a lead solder that has 63% lead and tin, and it melts at 360 degrees or 370 degrees, and you can melt pretty quick. And yes, that is Frank snoring in the background if you can hear it. What I'm going to use to solder these together is not regular solder. I'm going to use the lead-free solder. And the difference is the lead-free solder melts at 422 plus degrees. Regular solder 360 to 370, lead-free solder over 422. And why is that important? First of all, the lead-free solder, since it has less lead in it, it has more shear strength, which means it's going to be a stronger joint because there's no lead or less lead. The second thing is that the lead-free solder being a higher melting point, if you have a part like this and you decide to powder coat it, you're going to put it in an oven at 375 degrees. And since regular solder melts at 360, 370, you put it in the oven, it's going to fall apart. At least at 375 degrees, the lead-free solder will hold together and you'll be able to powder coat the part. As long as you don't induce any stress in it. And what I mean by inducing stress is like you have to bend the part and hold it together or clamp it to hold it and then solder it, and then there's a stress in there. So if you do heat it up, it might spring off. That's what I mean. So I'll show you how I made this, and we'll do the soldering on stainless steel with lead-free solder and an acid flux. Now the acid flux for this is very, very dangerous if you're going to do this. The solder is an acid flux. It has hydrochloric acid in it, usually, and zinc chloride, very dangerous chemicals. It'll burn your skin, it'll burn through plastics, it'll burn through almost anything if you leave it long enough. Very dangerous chemicals. If you splash it in your eye, very, very dangerous. Not only that, when you heat the part, the smoke that comes off is the hydrochloric acid, and the zinc chromate, zinc chloride, all of the chemicals that are burning and coming off. So you don't want to breathe in the smoke that comes off of there because that can burn your lungs and cause permanent damage. So let's get in. I'll show you how I made these really quick, and then we'll solder together. Now I started the whole process by making some paper templates of how I thought it would look. Basically, this basically folds up, and then you can take the parts and kind of work with it, cut it, trim it, put it in place. This is how this works. It goes like that around the curve. And you can put it in place and see how it works. So I made the paper template and I spent some time putting it in place and making sure that it fit properly. After I had the paper template complete and I could tape it together with regular masking tape or scotch tape, I just taped it together and made sure that it was going to fit where I wanted it. Then I took that template and I transferred it to the sheet of stainless steel and cut it out using my plasma cutter. After getting it all cut up, I had to clean up the edges, make sure the circular parts were round. Then I cleaned up the edges, did some deburring. Then I went to the brake and bent it. Now what I ended up with were two parts. I have the frame part, and this is going to match the front part of the car, the shape of the car. This is going to go around that core, the oil cooler itself. And then I made the scoop itself. This I bent by hand very slowly, and it fits right into this frame perfectly, right where I want it to. So this is what it looks like. And now we're going to go ahead and we're going to solder these two pieces of stainless steel together using a lead-free solder with an acid flux. Before I get started, I'm going to take a safety break. Pause button. We're talking about safety. If you plan on doing this kind of work and you want to solder some stainless steel, remember the fluxes that you're going to use have some very dangerous chemicals in it. Sulfuric acid, hydrochloric acid, zinc chloride. These chemicals will cause permanent damage. You get the acid, if the flux splashes on your skin, you will get a permanent burn. There's one right there, 20 years old. Just a little, it was on there for a second. The acid will dissolve your skin. It will dissolve almost anything you put it near. You have to be careful. It gets in your eyes, will cause permanent blindness. That smoke coming off when you heat it up, that smoke, hydrochloric acid smoke, any chlorides, that will get in your lungs, burn the alveoli in your lungs. You will have permanent lung damage. So please, if you're going to do it, take time to make sure you're doing it safely. Have some baking soda or something by in case it does splash. You can put some baking soda on it to neutralize the acid, and just take your time, because if you think I'm just going to do this real quick, I'm just doing a little piece, it won't take that long, you will get hurt, permanently hurt, faster than that just quick job you're going to do. So please, if you're going to do it safely. First, let me show you how this is done. Here's my piece of stainless steel, and in order to do this I need a few things. First, I need a brush like this that's not going to melt in the acid flux, so it's not going to dissolve. Usually a camel hair brush or that kind of brush will work. A nylon brush will melt. I have my solder, which is just regular lead-free solder that you can buy anywhere, but I got a big spool of that. I have my acid flux that I bought online. You can buy it online, or you can buy it locally, as long as it's an acid flux made for stainless steel. It'll say right on it. And I have my torch. So I'm going to light my torch. Okay, now I'm going to heat up the stainless steel a little bit, and you'll see that when I get it hot enough here, if I just put the solder on there and melt some solder, it just balls up. It's not going to stick. It will never, ever, ever stick to the stainless steel, no matter how hot you get it. It might stick just because when it cools down it might stick, but it's not going to wet to the surface, meaning the particles or the surfaces are not really wetting together. The particles of the solder are not sticking to the stainless steel itself. But watch what happens when I take and I put some flux on there. I'm going to take some acid flux and I'm going to put it on there. You're going to see it's going to clean the surface immediately, and it's going to smoke because it's hot. It's boiling off, but you don't want to breathe in any of those fumes. Stay away. You can see how that's still molten. Look at that. Look at that. It's still molten. It's still so hot. So I'm going to put some flux on there and watch what happens. Now I'm going to heat it up, and the solder is going to draw itself to the flux. And not only is it going to draw it to the flux, it's going to wet to the surface. So now it's forming a joint, and that flux is going to make the solder flow into the joint. The acid cleans the surface of the stainless steel, and now when I let that cool and not turn into a puddle, that solder is completely wetted to the surface of the stainless steel, and it's going to stick. It's going to create a very strong joint, and not only that, it's going to melt at a higher temperature. So I use the lead-free solder. So let's solder these two pieces together. I have a clamp over here just to hold the parts together. There's no stress. They're just sitting here. They're kind of loose. If I were to move this, it would move around. So there's no stress on the part. The clamp is just to hold it because it's going to be hot. I need a way to hold it. So the first thing I'm going to light my torch. Okay. So the first thing I'm going to do is I'm going to put some flux inside the joint, and you'll see it clean the surface of the stainless steel as I'm doing that. And if I put enough of it on here, it's going to seep down into the joint, and as I heat up the outside of the part, it will draw the flux into the joint. So I'm putting plenty of it on there. Again, do not hover your head over the part, because you'll smell the acid. It's a very strong acid smell, and you don't want to breathe that in. Very bad for your lungs. So now I have plenty of flux in here. Plenty, more than plenty. So now I'm going to start to heat the outside of the part, not the inside. I'm heating the outside where I want the solder to flow to. Remember, the solder is going to flow towards the heat. So I'm going to heat this up, and you'll see the smoke come off, and that's the flux starting to burn. That's the smoke you do not want to breathe in. Matter of fact, get a little fan and blow that smoke away from you. You breathe that in, you're breathing in sulfuric acid fumes. And when it's hot enough, just like any solder, the solder will begin to melt. Get some solder underneath, there's some heat underneath. And once the metal is hot enough, the solder will just naturally start to flow. So now I got it flowing there. When I get enough solder built up in there, I'm going to move the torch down towards the outside of the joint. It's going to draw, it'll draw the solder to the outside of the joint. And you should see that happen there. It'll start to flow through. You see it bubbling there a little bit, starting to flow. There we go, now it's flowing. And you move the heat around, and once you're done, just take the heat off and let it sit there and let it cool. Now the next joint I'm going to solder is the curved part. And something to notice, I just soldered this minutes ago, and you see the rust on there? That is the acid, the hydrochloric acid, rusting the iron that's in the stainless steel. There are free iron particles on the surface of the stainless steel. The acid and the flux gets in there and it rusts it immediately, so we'll have to neutralize that when we're done. But now I will do the same thing for this joint, and again I will put my flux on there, and I can clean up that rust by doing that, but you don't want to mix the rust in with the flux because it'll contaminate your flux. So I'm going to just put some flux on the joint right here. Make sure you put your brush down where it's not going to drip or cause a problem. And yes, Frank is still snoring on the chair. Okay, now again I'm going to heat away from this joint. I don't want to get any solder in that joint. I don't want to reheat that joint, so I'm going to heat here, and I'm going to heat out here, put the solder here, then I'll walk it towards that joint to make sure I don't overheat it. And again, that smoke coming off, do not breathe that smoke. Okay, so I got a puddle going. I'm going to take the heat off. Now, you can see how I'm going to heat up this part here. I'm going to put some solder in there like that. I'm going to let it melt. Now I can use the flux to move that solder where I want it to go. So I'm going to heat it up, take some flux, not breathing it in, put some flux up here. You can see how that moves. See how it moves up there? Put some flux up there, get it to flow up towards the top. Put some on the bottom. Make sure I have flux where I want it. Now I can probably walk it straight down that joint. Just like that by heating it up. Don't want to go too far. You heat it up too much, it's going to seep right through the joint. But I can move the solder with my brush, with the flux on it. And I have that wetted fairly well. I'll put a little bit more down here to get the flux to flow and get the solder to flow down there a little bit. I just don't want to reactivate or reheat my original joint, because that would be bad. See that solder starting to flow? More flux up here. So the flux will boil off, and once it reaches about 420-22 degrees, my solder will start to flow. Now I'm running the risk of that upper joint starting to melt, and I don't want to do that. So I'm going to add some more solder up here and just get that to flow, just like that. And once I'm happy with it, let it start to cool. It starts to harden a little bit. Oop, got a big chunk there, but that's okay. Just going to melt that. I can use my brush to move that. Get the flow nice. And once I have a nice fillet in there with the solder, like that, I can let the heat off and let it cool. Okay, now that the part is soldered, the temptation is going to be to wipe the area. I rinsed this off with water, by the way. The temptation is to want to wipe up any leftover flux with a paper towel. But don't do that, because then you'll have a towel that's full of hydrochloric acid and zinc chloride and all kinds of chemicals. So baking soda is all you need. We'll neutralize. Just put some baking soda around the area here to make sure I don't have any acid left over. And to neutralize the rusting in the part, I'm going to put baking soda on it. And I'm just going to rub it in to the part around where the rust is. And you'll see when you do that, the baking soda is slightly abrasive. Not only is it going to neutralize the acid, but it'll also take off the rust. The parts that oxidize. Those are the fine ions of iron that were left on the surface of the stainless steel. So now here's my finished part. I washed it off with water just to clean it up. And inside you can see all the rust is gone from where the oxidation and the iron ions were sitting on the surface. There's still a little bit there, but that's not a big deal. I'll clean that up. I have my solder joints. And what's nice about using solder instead of welding is you won't discolor the stainless steel. The stainless steel won't turn all different colors because you heated it up and melted it. So let's go test fit and see how it works. So there you have it, fabricating parts by soldering stainless steel. Hope that helps you out. Thanks for stopping by Pete's Garage.